I I didn't really look at these notes before I printed them off. Yours say Vinny Testaverde and the Washington Redskins. Uh, so if I had noticed that, I would have changed it. But I did. I changed it on mine just to be more modern. Jaden Daniels is standing on the 40-yard line of the Washington Commanders when he throws a pass towards their end zone. The equation that represents the path of the ball is y equals negative 0.0975x squared plus 3.9x plus 6, where x represents the number of yards from the goal and y represents the number of feet the ball is above the ground. Okay. So, looking at this, there's three important things. Here's our equation. Let's go ahead and put that into our calculators. Y equals negative 0.0975 x squared plus 3.9x plus 6. Another important thing where x is the number of yards from the goal, so it's your distance, basically. And y represents the number of feet the ball is above the ground, so the height of the football. So he's throwing the football. The x values is how far it's traveling down the field, and the y values is how high in the air it is. Okay. All right, now, on each of these quadratic application problems, you are going to need to adjust your window to the problem. So let's look at what that could look like. Okay, your x minimum, what is the lowest x value that we're going to have in our window? What's the lowest amount of distance this ball can travel? 0, right? As he's dropping back in the pocket, right here, ball's in his hands, right? It hasn't left his hand. So 0 is going to be our x minimum. X min 0. Oh, and up top on that top row, the gray button's up there. There's a window button that we're going to be using. So that's what this window represents. So you can go on that top button up there. The gray buttons, there's window, the second button. And it'll pop up just like what you see here. Window on the top row. So X-min is going to be 0. If we're standing on the 40-yard line, what's the furthest distance he could throw it towards the end zone? This one isn't a trick question. If he's on the 40-yard line, how far can he throw it? How far is it to the end zone, right? It's 40 yards. We're going to go a little bit beyond that. The end zone is actually 10 yards deep. So let's say that he can throw it all the way through the back of the end zone. So let's just say even 50. It's always better to overestimate these than to underestimate them. So I'm going to add 10 more yards to it. And let's say 50 yards. Then right here, this SCL, that just means X scale. So when you have your graph, you know how you have like little marks representing numbers. That's just however many you want those, or however much you want those marks to represent. So 0 to 50, let's just say that each mark is worth 10. So there's going to be a total of 5 marks on your graph, your X scale. Each mark that you see is worth 10, basically. So X scale, 10. And then your Y min. Y is the height of the football. What's the lowest this football can be? 0, meaning what? If the football has a height of 0, where's it at? It's on the ground, right? If it has a height of 0, that means it's on the ground. It's not going to be able to go below 0 because the ground level is 0. So we're just going to say Y min 0. That means it's on the ground. And then our Y max, how high in the air do you think he can throw it? This one is just a pure estimation. What's a good starting point, you think? 10 feet in the air? He can throw a lot higher than that. Let's go a little bit higher than that. Let's go higher than that. 25. Let's start there, okay? Y max 25, 25 feet in the air. So Y min 0, Y max 25, and then Y scale, let's just say 5. So 0 to 25, each mark represents 5. Okay, should be putting these in your window, and then we're going to graph it. So we've set up our window, now let's graph. Oops. All right, what happened to my graph? Hmm. It went really high. We can't see the top of it, can we? So let's go back to our window and let's raise that Y max because the Y max just tells you how many Y values you could look up to. So let's raise that Y max from 25. Let's go to 50 on our Y max. So you might have to play around with it like this and get the adjustments just right so you can have a graph that like fills your screen. So let's go to 50 and let's change our Y scale to 10 just to have fewer little tick marks. Okay. So your window, you can just kind of play around with it. Once again, it's better to overestimate than to underestimate. If you underestimate like we did there, you won't be able to see enough information. But if you overestimate it, it'll just be smaller. So I have 0, 50, 10, 0, 50, 10. Now let's graph it. Okay, now I can see the full entire graph from start to finish. I'm going to go ahead and sketch it real quick. Nothing too crazy. So my max on my graph was 50 up and 50 to the right. It looks something along those lines. You're just kind of giving a rough sketch, and we're just drawing those little tick marks. All right, so there's our window and our graph all set up. So now we're going to start answering questions based on information that we find in our calculator. What? Did you? Okay, this first question, how high is the ball when it crosses the 30-yard line, 15-yard line, 5-yard line? All right, so once again, we're on the 40-yard line. Okay, so before we do anything, when it crosses the 30-yard line, so we're going from the 40 to the 30, so we've only really traveled 10 yards, okay? 15-yard line, 40 to the 15, where that is a traveling 25 yards. And then from the 40 to the 5-yard line, that's traveling 35 yards. Okay, it's important to make that distinction because we have to know the distance that it's traveling and not necessarily the like inputting that distance. All right. Now, when a question gives you the x value, okay, these are all x values, the distance that it's traveled, and it's asking for a y value, we're going to do second trace and then the first option, 1, which says value. Okay, so second trace 1. When it gives you the x's and it's asking you for the y's, we're going to use second trace 1. So second trace on my calculator, 1. Second trace 1. Second trace 1. Good, good. Ah, should have an x equals, a little blinking light. You're good. Second trace. Wait, go back to your y equals. 0.975. You're just copying down that right there. Yes. It says x equals and a blinking light. And we're going to enter these distances that we found. So we're not going to enter 30. We're going to enter 10 because the ball has only traveled from the 40 to the 30, which is 10 yards. So x equals 10. And I'm going to press enter. And it should bring up your exact y value for where you are. Mathis. Hello? All right. I'll bring you to that exact point. It says x equals 10, y equals 35.25. So 35.25 feet. That's how high in the air it is. Now I'm just going to repeat that process for the other two options. So when it says 15-yard line, we've got to do like the distance traveled. It's traveled 25 yards. So second trace 1, x equals, we're saying 25, enter. 45.5625 feet. That's the height of it. And then one more time, second trace 1. We're saying the ball has traveled 35 yards. So I'm going to enter 35 and press enter. 23.0625 feet. So we're using all this in the calculator. Second trace 1 when it gives you the x value. So all that's on your calculator. When it gives you the x value, second trace 1, and then you can find the y value. All right, on number 2. This is sort of an inverse of the one we just did. Now it's giving us the y value a height of 15 feet, and it's asking us to find the x value, how far it has traveled. So this time, since this is a y value, I'm just going to enter that into my y2. So I'm going to go back to my y equals, and y1 I have my equation, but in y2 I'm going to enter the y value it's asking me for. So y2 I'm going to enter 15. Y1 is my equation, y2 I'm going to enter the y value it gives me, which is 15. Then I'm going to graph it again. There should be a line just going straight through the middle of your graph. That's that 15 foot mark. All right, when we're doing these operations, we're going to go second, trace, and then a new one, number 5, which says intersect. Because we're looking where the lines are going to be crossing or intersecting. So when it's giving you the y value, you've got to put that y value into y2. And then when you graph it, we're going to do second, trace, and intersect. All right, now when we do these, I'm just going to move my little cursor. So my graph looks something like that. I'm just going to move my little cursor as close to the intersections as possible. So I'm going to do one at a time. I'm going to go to the right one first, let's say. Go to the right intersection where the two lines cross. And I'm just going to get my cursor as close to that crossing point as I can. Then once you get there, you're just going to press enter 3 times. 1, it'll say second curve, press it again, and then guess 1 more time. And it'll give you the intersection point. And the x value is what we are taking from this. So I moved my cursor as close as I could right over here, got it about right there, and then I pressed enter 3 times. Just sped past them. It'll give you your x value for when y equals 15, 37.541, sorry. Then now I've just got to repeat that process for the intersection on the left. So second trace 5, and I'm just going to move that cursor all the way over. This might take you just a second. Cursor doesn't move very fast. I want to move it all the way over to that left intersection on the left side. And I'm going to get as close as I can get, the closest option, and then I'm going to press enter 3 times. 1, 2, 3. And this one, 2.45, and then there's 2 8s, so the second 8 would make the first one round up to a 9. It says, where is the ball located? We're just going to say how far it's traveled. It's traveled 37.541 yards and 2.459, which makes sense, right? Because as you're throwing it upwards, it's going to cross 15 feet, but then also as it's coming down, it's going to cross 15 feet again. Okay, just ask for where the ball is at 15 feet off the ground. So on the way up and on the way down. 2 different points, 2 different intersections. All right, this number 3 question. If nobody catches the ball, approximately where on the field will it land? Okay. Here, we're looking for where the ball hits the ground or where the height is 0. So we're actually looking for the x-intercept as we've done before. So I'm going to go into my second trace to the 0 function. Second trace 2. second trace 2, and I'm looking for this x-intercept down here where the ball is going to touch the ground, where the y value is going to equal 0. So when it says left bound, I'm going to put my cursor up and to the left of it. Not very much, but just enough to be up and to the left of it, where I can still see it. And actually, when I press enter and I go right bound, this graph keeps on going, but we don't care about that because the ball's not going to go under the ground. So we're only looking at that 0 up, but this graph technically does still going. So I'm going to move my cursor to where I can't even see it down below the graph and to the right. So once I can't see it, I'm just going to press, maybe 5, 6 more times. 1, 2, 3, 4, 5. Just make sure that you're to the right of the intersection, right bound, and then I'm going to press enter, and then guess I want to bring it back up to where I can see it again and try to get it as close to 0 as I can. Basically, if you look at your y values while you're moving the cursor, you want your left bound to be positive y values and your right bound to be negative y values as you're moving your cursor. You can see the values changing. Y values positive for left bound and negative for that. So when I did my 0 function, I got x equals 41.483. So he's throwing it 41.483 yards. Okay, so that's the maximum distance he's getting out of it. It's landing 41.483 yards from him. So approximately, where is that ball going to land at? If he's on the 40 and he's throwing it 41 yards, where is that ball going to land? In the goal, right? In the end zone. Okay, so we could say, because it's asking where will it land, in the end zone. So we're not only calculating a distance, but you have to actually answer the question as well. It asks approximately where on the field will it land. We said in the end zone because he's throwing it that 40 yards distance away he is. Then number 4 is fairly simple. What is the maximum height of the ball? The ball is the graph with the curve that looks like that. So we're looking for this maximum height at the top right here. So we're going to go second trace. We've done this before. Maximum, number 4. Second trace maximum. And then we're going to use our cursor to go to the left of our vertex up top. Left bound, we go to the left, press enter. Right bound, we go to the right and press enter, and then guess back to the middle. And it'll get you that maximum point. For me, I got 20 and 45. X equals 20, Y equals 45. Yeah, we're looking for this up here, so you can bring it. You just need to be just to the left of it. So right there is good for left. And then you can press enter. And then right, we just need to go to the right side of it. There you go, right there. And then guess back to the middle. And there you go. So maximum 20 and then 45. Wake up. Wake up. Did you get there with the maximum? Nice. Maximum. Okay, cool. So our maximum point is 20 and 45, but which of these is the maximum height? 45, the y value. So 45 feet is the maximum height. Where did the maximum height occur? Well, this is 20 yards from him, right? That's the distance we're calculating. So if he's on the 40 and he threw it 20 yards, where are we now? We're going in. So we're like end zone's that way. I'm at the 40 and I threw it 20 yards that way. Basically, yes. So the 20-yard line. So we threw it 20 yards to get the maximum height. So where did it occur? The 20-yard line. You got to use a little bit of logic, a little bit of reasoning in these questions. Once again, because that maximum point was 20 yards away, we're throwing to the end zone. So he's on the 40. We threw it 20 yards. It's at the 20-yard line. All right, now the domain. What is the domain for this problem? No. That has been the domain for all of our quadratic questions up until this point, okay? When you start using real-world applications. The reason being, my domain is my x values, right? The distance traveled, okay? Where's the ball starting? It's starting at 0 because it's starting with me right here. I have the ball in my hands. I'm not going to pass it negative infinity yards behind me, right? So that's where that little bit of like logic and reasoning has to come into play. The ball is starting at the quarterback, at Jayden Daniels. So he's starting 0 distance either direction. So that's where our domain starts, is at 0. No, because he's throwing it, and how far is he throwing it? Which one of these questions would get us the maximum distance he throws it? If nobody catches the ball, approximately where on the field will it land? When that ball hits the ground is what we calculated for this one. So 41.483 yards is the distance that he threw it in the air. So 41.483 is the maximum distance we're getting out of that throw. Well, it was just saying like he's rocking back, he's just throwing a ball up, and it says if nobody catches the ball, this is where it's going to land. Now, if somebody catches it, I mean, it's going to be different, you know. Yeah. And then lastly, number 7, the range for this problem, the y values. What's the lowest y value I can have in this problem? Y values are my height, right? So what's a height of 0? I'm saying like, what does that mean? If the football has a height of 0 right now, said it earlier. It's on the ground, right? So that's just my starting point. We can't start below the ground. The lowest it's ever going to be is on the ground, so 0. And then what was my maximum height? Not 20. Maximum height of the ball, the 45. So we're really just using these answers before to answer our questions for domain and range. All right. Are there any of these 6 right here that I need to go over again and just re-explain? We might have lost track on. Any of these 6 right here? It's a lot of calculator doing stuff, but hopefully you wrote down all the different operations you do for each one. Okay. Anybody need me to go over? Again. Okay. That's where we'll end it today. Tomorrow we will go into 7-6 notes. So once again, tomorrow we'll have a notes packet or a notes. We'll be working on notes tomorrow. That way on Thursday and Friday when I'm not here, y'all can have an assignment one day and then another assignment on Friday. All right. Thank you for your attention.